Talking Trees with Lily and Jad. Welcome to our weekly recap. Today we're diving into key insights on trees and their environmental interactions, covering topics from photosynthesis and the effects of urban settings to best practices in pruning and advanced tree measurement techniques. We'll also explore the latest in 3D modeling, stability analysis, and the biodiversity tied to veteran trees. Get ready for a comprehensive look at tree care, preservation, and their essential role in the ecosystem.
Hey everyone, welcome back. It's time for another deep dive. You know what that means.
Yeah, we're taking all that cool stuff from Talking Trees last week. And
Exactly. We're going beyond the headlines, so to speak.
And trust me, there's some seriously fascinating stuff in there.
For sure. Okay, so to refresh everyone's memory, last week on Talking Trees, we covered a whole bunch of topics.
It was a packed week.
It was. We had photosynthesis, planting big trees, tree pruning techniques.
Measuring trees, too. And don't forget that Adbian software.
Oh, yeah, that was a mind bender. And then to round it all off, those amazing tree microhabitats.
Those little worlds inside the trees themselves.
Exactly. So are you ready to dive in?
Absolutely. Let's unpack all this amazing tree knowledge.
Awesome. So let's rewind back to Monday's Talking Trees, where we were talking about those city trees and how they deal with stress, especially those growing near busy roads.
Right. That study comparing different tree species and cultivars.
Yeah, how do they handle those tough conditions with all the traffic and pollution and everything?
Well, they use some pretty sophisticated tools to measure the impact, like fluorescence spectroscopy, for instance.
Wait, hold on. How does light tell you if a tree is stressed?
Okay, so chlorophyll, the stuff that makes leaves green, it captures sunlight for energy, right? But it also gives off a faint glow called fluorescence. Scientists can measure this glow to see how efficiently the tree is photosynthesizing. Basically, a stressed tree won't glow as brightly.
So it's like checking the tree's vital signs to see how it's coping with the city.
Exactly. And they also looked at the amount of chlorophyll in the leaves, and even how those tiny pores on the leaves, the stomata.
Yeah, they control the gas exchange, right.
Right. They were looking at how easily those were opening and closing. What they found is that some species are like urban superheroes. They can handle the pollution, the heat, the compacted soil, all that jazz, and their photosynthesis barely even flinches.
So like those ginkgo trees, right?
Mm-hmm.
They always seem to thrive in cities.
The ginkgo biloba, yep. They were real champs in this study. Barely any change in their photosynthetic activity. It's probably because they've been around for ages, literally millions of years. They've seen it all.
They're like the ultimate survivors.
Pretty much. But then you have other species that are more sensitive. You put them in the concrete jungle and their photosynthesis tanks.
So that's a big takeaway for anyone thinking about planting trees in a city.
Mm-hmm.
It's not just about how pretty the tree is, but whether it can actually survive the city life.
Exactly.
Oh.
Knowing which trees can handle the heat literally can save a lot of time, money, and heartache.
Okay, so moving on to Tuesday, we shifted gears from the microscopic to the massive. We were talking about planting big trees, remember?
Yeah, trying to move those already established giants.
I know. I was especially intrigued by the idea of root pruning. I mean, cutting roots just seems counterintuitive when you're trying to help a tree establish itself.
Right. You'd think you'd want all the roots you can get.
Right.
But root pruning is actually crucial when you're moving a big tree. It's all about encouraging the tree to grow a compact, dense root system that can be moved more easily and has a better chance of surviving the transplant.
So you're essentially giving the tree a head start on adapting to its new home before it even gets there.
Exactly. It's like pre-gaming for the big move.
Okay, that makes more sense. But are we talking about just lopping off a bunch of roots?
There's definitely a method to the madness. The sources we looked at actually outline two main approaches to root pruning: selective pruning and non-selective pruning.
Okay, break those down for me. What's the difference?
Well, selective pruning is more like a surgical procedure, you could say.
Oh.
You carefully choose which roots to cut, usually targeting the larger structural roots that extend way out beyond the main root ball.
So you're encouraging the tree to focus on the smaller, finer roots within the root ball.
Exactly. That way, when you dig up the tree, you're not losing a ton of important roots.
So when would you use the non-selective approach?
Non-selective pruning is like giving the tree a root buzz cut. You essentially prune all the roots within a certain radius.
Wow, that seems drastic.
It can be, but it's sometimes necessary if you need to move a tree quickly. It's definitely more stressful for the tree, though, because you're inevitably cutting some of those important feeder roots.
So it's a trade-off, speed versus the long-term well-being of the tree.
Exactly. It depends on the situation, the type of tree, its age, and the expertise of the arborist.
Speaking of expertise, the whole idea of transplanting a mature tree like the ones you see in parks, it just boggles my mind. How on earth do they even begin to move something that big?
It's a massive undertaking. You need specialized equipment, a skilled team, and a super detailed plan. You're basically uprooting a living giant and trying to relocate it to a completely different environment.
So walk us through it. It can't just be digging a hole and plopping it in,
Oh,
right?
no, not at all. Timing is super important. It's usually best to transplant trees during their dormant season when they're less active and better able to handle the stress.
Makes sense. Less trauma for the tree.
Right. Then you have to carefully excavate a trench around the tree, severing the roots beyond the root ball and wrapping it up in burlap for protection.
So you're essentially creating a giant portable root ball.
Exactly. The size of that root ball is critical too. Too small, and you risk damaging the root system. Too big, and it'll be impossible to move.
It's a delicate balance.
It is. Once the root ball is prepped, you need heavy machinery like a tree spade or a crane to actually lift the tree out of the ground and transport it.
I can't even imagine. So what happens at the new site?
Well, the planting hole has to be prepped and ready to go. It needs to be the perfect size to accommodate the root ball, and the soil has to be amended with the right stuff to ensure good drainage and nutrients for the roots.
So it's like creating a 5-star hotel for the tree's roots.
Pretty much. Once the tree is in the hole, you remove the burlap, backfill with soil, make sure everything is nice and snug.
No air pockets.
Exactly. And of course, the aftercare is just as important as the actual move itself. Watering, mulching, sometimes even staking the tree for support.
Just to help it get settled in.
Right. Transplanting a mature tree is definitely a big commitment. But when it's done right, it's amazing. It's like giving a tree a second chance at life in a new space.
It's a pretty amazing feat when you think about it.
It is. It shows what we can do when we really understand and work with nature.
All right, so moving on to Wednesday's Talking Trees, we scaled things down a bit and focused on pruning, especially for those older, more venerable trees.
Pruning is often seen as just a cosmetic thing, but it's so much more than that. It's vital for a tree's health, especially as they age.
Remember we talked about how pruning older trees comes with a whole different set of challenges.
Absolutely. You have to be extra careful with older trees. Their growth patterns change over time. They become more susceptible to disease. So when you're pruning, you need to really assess the tree's overall condition and how much stress it can handle.
So you're not doing more harm than good.
Exactly. You want to help the tree thrive, not accidentally weaken it. And then there was that European tree pruning standard we talked about.
Yeah, that sounded pretty comprehensive. What stood out to you about it?
Well, it really emphasized a holistic approach to tree care. It's not just about aesthetics. It's about considering the tree's overall health, the surrounding environment, even the safety of the people who are working on the tree.
So it's about finding that balance between the tree's needs, the ecosystem's needs, and our own human needs.
Exactly. And it's about doing it all in a way that's safe for everyone involved.
All right. Let's switch gears again. On Thursday, we got into the world of measuring trees. And it turns out it's a lot more complex than just grabbing a tape measure.
Way more to it than that. I mean, a tape measure might be fine for a small tree, but when you're dealing with big trees, especially in an urban setting, you need more sophisticated tools.
So what kind of measurements are we talking about? I'm guessing it's more than just the height of the tree.
Right. Height is important, of course, but we also need to know the circumference, the crown width, the volume of the trunk. All those measurements help us understand the tree's overall condition, its stability, how it's growing.
So it's like getting a full physical for the tree.
Exactly. And then we got into some really cool technology, 3D tree scanning.
Yeah, that one blew my mind.
I know, right? It's amazing.
Absolutely.
It's like creating a digital twin of a tree, using lasers and sensors to capture millions of data points on the tree's surface. And then you can create this incredibly detailed 3D model.
So you can see every nook and cranny of the tree.
Yes, even the parts you wouldn't normally be able to see, like internal cavities or signs of decay.
Wow, so what can you do with all this data?
So much. Arborists can use it to assess the risk of tree failure more accurately. They can see exactly where a branch might be weak, where a cavity might be compromising the tree's structure. It helps them plan pruning or cabling operations much more precisely.
So it's like having X-ray vision for trees.
Exactly. You can see inside and really understand what's going on beneath the surface. And all this data feeds into this standard for data collection, the Individual Tree Data Standard 2021. It's all about creating a universal language for describing tree data, so everyone's on the same page.
That makes sense. It's like having a common dictionary for trees.
Right. And then there's this cool tool called the ADBN STEM scan that helps create those detailed 3D models.
Okay, so that leads us to Friday, and we were back in the world of software talking about ADBN. This one was a bit over my head, I'll admit.
Yeah, it's pretty high-tech stuff.
Can you give us the non-techie explanation of what it does and why it's important?
Well, think of ADBN as a high-tech stability detective for trees.
Okay, a tree detective.
Exactly. It takes those 3D models we were just talking about and uses algorithms to analyze the structural integrity of a tree. It looks at things like wind loads, the tree species, and then it calculates how likely that tree is to fail under different conditions.
So it's like putting the tree through a virtual wind tunnel.
That's a great way to think about it. ADBN can help arborists decide if a tree needs to be removed because it's too risky, or if it can be saved through pruning or cabling.
So it's not just about saving trees, it's about saving lives too.
Absolutely. ADBN helps prioritize tree care efforts and make sure we're focusing on the trees that pose the greatest risk to people and property.
And it probably helps allocate resources more efficiently too.
Exactly. Especially when budgets are tight.
It sounds like ADBN is taking a lot of the guesswork out of tree risk assessment.
It really is. It's all about using data to make more informed decisions, which is better for everyone, both people and trees.
All right, let's wrap up this week with Saturday's episode of Talking Trees, where we went on a journey into those amazing veteran trees, you know, the wise old trees that are like little ecosystems in themselves.
Ah, yes, those veteran trees. They're incredible. Every little nook and cranny, every dead branch, every bit of peeling bark, it's all a potential habitat for a whole array of organisms.
It's mind-blowing to think that those tiny spaces can support so much life. What kind of creatures are we talking about here?
Oh, you name it. You've got insects, spiders, fungi, lichens, mosses, even small mammals like bats and squirrels that take shelter in the cavities, and they all play a role in maintaining the biodiversity of the forest.
So those veteran trees are like biodiversity hotspots.
Exactly. And the older and more complex the tree, the more microhabitats it's likely to have.
I remember we talked about a practical guide for inventorying those microhabitats.
Yeah, it's like a field guide for exploring the miniature worlds inside those trees.
So it helps you identify different types of microhabitats and the creatures that live there.
Exactly. It's fascinating stuff. For example, a hollow in the trunk could be a perfect nesting site for a woodpecker or a roosting spot for bats. A dead branch, while it might look lifeless, is actually teeming with insects and fungi.
So it's all about looking at trees with a new perspective, seeing them not just as individual trees, but as complex ecosystems.
Exactly. And it makes you realize how important it is to protect those veteran trees. They're not just beautiful to look at, they're crucial for a healthy forest.
Well, I think we've done a pretty good job unpacking the first half of our Talking Trees week. From the tiny world of photosynthesis to the massive undertaking of moving mature trees. It's been quite a journey.
It has. And we're just getting started. There's so much more to explore and discover about these incredible organisms.
Yo, welcome to the week's recap, where trees and science meet. From photosynthesis grinding on the city street, Monday's all about that green machine, doing photosynthesis working unseen. Fluorescent lights, chlorophyll insights. We measure the glow, which trees thrive by the roadside, which ones grow slow. Tuesday's got roots, pruning like pros, selective or not. It's all about how that growth goes. Move big trees, risk the stakes, it's a heavy lift, but the profit's there if the knowledge is swift. It's Talking Trees with Lily and Jad, where knowledge grows and the passion's mad. From roots to leaves, we're breaking it down. In the world of trees, we're the talk of the town. Wednesday's pruning up top, gotta do it right. Mainstream or veterans, each tree's got its fight. It's stress and strength, thinking long-term life. Each cut and trim, surviving the strife. Thursday, we're clocking tree height and width, measure the spread and trunk girth, lifting myths, 3D scans, models so precise. With data standards, we're cutting advice. Friday's ADBN tech on the scene, with 3D models showing tree stability clean, assess, protect, with algorithms tight, for a future that's green and a city that's bright. Dive deep into the micro-homes, veteran trees where ecosystems roam, from beetles to birds, life in old wood, every nook, every knot, biodiversity's understood. It's talking trees with lily and jad, where knowledge grows and the passion's mad. From roots to leaves, we're breaking it down. In the world of trees, we're the talk of the town.
You know, it's amazing when you think about it. We go from those massive trees to the microscopic world of photosynthesis, and it's all the same organism.
I know, right? Talk about a range. And speaking of zooming in, remember that study on how urban environments affect photosynthesis?
Yeah, the one where they used all that fancy equipment to measure the impacts.
Right, like fluorescence spectroscopy, for example.
Yeah.
I have to admit that one went a bit over my head.
Yeah.
Can you break it down for us again?
Sure. It's all about light. So chlorophyll, the pigment that makes leaves green, it captures sunlight for photosynthesis.
Right, we all learned that in school.
Exactly. But chlorophyll also emits a faint glow when it's exposed to light, and that glow is called fluorescence. And scientists can actually measure that glow to see how efficiently a tree is photosynthesizing.
So the brighter the glow, the healthier the tree.
Pretty much. They compared trees growing near busy roads with those in a quieter park setting, and they found that some species, like the ginkgo biloba, barely showed any changes in their fluorescence.
Even with all the pollution and heat and everything.
Yep. It's like they have this built-in shield against urban stress.
So what's their secret?
Well, ginkgos are known for being tough. I mean, they've been around for millions of years, surviving all sorts of environmental challenges. This study actually pointed to their efficient stomatal regulation as one of the reasons they did so well. You know, those tiny pores on leaves that control gas exchange.
With stomata.
Yeah. Right. So the ginkgos in the study were really good at adjusting their stomatal opening to maintain a good balance, even under stress.
So it's not just about being tough, it's about being adaptable.
Exactly. And knowing which species can handle the urban heat island effect is super important for city planners and arborists.
Okay, back to planting large trees. I'm still trying to wrap my head around root pruning. Cutting roots before you try to help a tree establish itself just seems so counterintuitive.
I know it seems weird, but remember, we're trying to encourage the tree to grow a compact, fibrous root system, one that can be moved easily and has a better chance of taking root in its new location.
Okay, so it's all about promoting the right kind of root growth.
Exactly. We talked about selective and non-selective pruning, right?
Right, so with selective pruning, you're carefully pruning specific roots to encourage more growth within the root ball itself.
Exactly. That way, when you dig up the tree, you're not losing a ton of those important roots.
And non-selective pruning is more like a last resort.
Yeah, it's more like a root buzz cut. You prune all the roots within a certain radius. It's usually done when time is limited, but it can be a lot more stressful for the tree.
So I guess it all comes down to choosing the right approach for the situation.
Absolutely. It's not a one-size-fits-all thing.
Now, the actual process of transplanting a mature tree, that still feels like magic to me. How do they even begin to move something that big?
Well, first you have to choose the right tree. Not every tree is a good candidate for transplanting. It depends on the species, the age and health of the tree, the structure of its root system.
So it's not just about picking the prettiest tree on the block.
Nope. You have to think about the tree's overall health and its ability to handle the stress of being moved. Then you have to prep the tree carefully. It is. Then, at the new site, the planting hole needs to be perfectly sized, and the soil needs to be just right for the tree to thrive.
So it's not just about digging a hole and dropping the tree in.
Definitely not. It's about creating the ideal conditions for the tree's roots to reestablish themselves.
Okay, so now the tree is in its new home. What happens next?
Well, then it's all about aftercare. Watering, mulching, sometimes even staking the tree for support. It takes a lot of care to make sure a transplanted tree survives and thrives.
It's like a major surgery and recovery period.
Exactly. But when it's done right, it's amazing. It's like giving that tree a whole new lease on life in a new place.
Now let's get back to the microscopic world of photosynthesis. I know we talked about the urban environment study, but I think it's worth revisiting the actual science behind photosynthesis itself. It's fascinating how these tiny processes at the cellular level can have such huge implications for a tree's survival.
It really is. It's the foundation of life as we know it. I mean, plants converting sunlight, water, and carbon dioxide into energy and oxygen, it doesn't get much more fundamental than that.
And trees are like the ultimate energy producers.
Absolutely. But you're right, those urban environments, they can throw a real wrench in the works. I mean, think about it. Air pollution can clog those tiny pores on the leaves, the stomata.
Which are essential for gas exchange, right?
Exactly. And then you have the urban heat island effect, which can increase water loss through transpiration, making it harder for trees to stay hydrated. And compacted soil, which can restrict root growth, making it tougher for trees to get the water and nutrients they need.
So it's like an obstacle course for trees trying to survive in the city.
Pretty much. And all those stressors can disrupt photosynthesis, which means less energy for the tree to grow and thrive.
And I remember the researchers use more than just fluorescence spectroscopy to measure those impacts, right?
Yeah.
What other techniques did they use?
Oh, yeah. They looked at a whole bunch of things. They measured chlorophyll content to see how much of that energy-capturing pigment was in the leaves. They also measured stomatal conductance to see how easily carbon dioxide was getting in and water vapor was getting out. And they measured water potential, which basically tells you how hydrated the tree is.
So it was a pretty comprehensive approach to understanding how these trees were dealing with city life.
It was, and the findings were really interesting. We talked about the ginkgos, how they seem to shrug off the stress.
Like they're immune to it.
Right. But other species weren't so lucky. They showed real declines in photosynthesis, they had less chlorophyll, and their stomata weren't functioning as well. All signs that they were struggling.
So it's not just about picking any tree for the city, it's about choosing the right tree for the right place.
Exactly. We need to understand which trees can handle the specific challenges of that urban environment.
Okay, let's circle back to tree pruning techniques for a minute.
It's a skill that requires knowledge of tree biology and different techniques. Improper pruning can actually damage a tree and make it more susceptible to disease and pests.
So there's a right way and a wrong way to prune a tree.
Absolutely. And there are different techniques for different purposes. Some of the most common techniques are heading back and thinning out. Have you heard of those?
I have, but refresh my memory, what's the difference?
So heading back is when you shorten a branch by cutting it back to a bud or a lateral branch. It helps control the size and shape of the tree and encourages bushier growth.
Okay, so it's more like a shaping technique.
Yeah. And then thinning out is when you completely remove a branch back to its point of origin.
Ah, okay. So that's more about opening up the canopy and reducing weight on the tree.
Exactly. It can also help improve air circulation and let more light into the inner branches.
So both heading back and thinning out have their place depending on the goal you're trying to achieve.
Precisely. And you also have to consider the species of tree, its age, its overall health. It's not a one-size-fits-all approach.
It's like personalized tree care.
That's a great way to put it. And of course, safety is super important when it comes to pruning, especially with large trees.
Oh, absolutely.
Arborists use all sorts of specialized equipment and techniques to make sure they can access the tree safely and do the job properly.
It's a pretty skilled profession.
It is.
Now let's dive back into those tree microhabitats. We talked about all the amazing creatures that live there, but I want to talk more about why those microhabitats are so ecologically important for the forest as a whole.
Well, it's all about biodiversity and balance, right?
Right.
Those microhabitats provide all these little niches for different creatures, and they all play a role in keeping the forest healthy. You've got insects that break down dead wood, you've got fungi that decompose organic matter and release nutrients back into the soil.
So it's a whole cycle of life and death and renewal all happening in these tiny spaces.
Exactly. And the more diversity you have in those microhabitats, the more resilient the forest is as a whole.
So it can handle disturbances like drought or pests or disease outbreaks.
Exactly. It's like having a backup system for the forest, which is why it's so important to protect those veteran trees, because they provide the most microhabitats.
So it's not just about protecting individual trees, it's about protecting the whole interconnected web of life.
Well said.
Now, let's get back to the tech side of things. 3D tree scanning and ADBN software. We talked about how they're changing the way we manage trees, but I'm curious about their potential for conservation efforts. Could they be used to help protect trees in the long run?
Absolutely. 3D scanning can help us create incredibly detailed models of ancient trees or heritage trees, so even if the physical tree eventually dies, we have a record of its structure and form.
It's like creating a digital archive of these irreplaceable trees.
Exactly. And those models can also be used to study those trees, how they grow, how they respond to environmental changes. That kind of information is really valuable for conservation.
And what about ADBN? How could that help with conservation?
Well, ADBN could be a game changer for assessing tree stability in areas that are prone to things like landslides. By identifying trees that are at high risk of failing, we can focus our conservation efforts where they're needed most.
It's like using technology to give a voice to those vulnerable trees.
Exactly.
Well, I think we've covered a lot of ground today, revisiting some of those key topics from Talking Trees and really diving deep into the details.
It's been a great discussion.
It has. And I hope our listeners are feeling inspired to learn even more about these incredible organisms that play such a vital role in our lives.
Me too.
Thanks for joining us on this deep dive. We'll be back next week with a whole new topic to explore. Until then, happy listening.
Thanks for tuning in to this week's recap. We hope you enjoyed exploring the fascinating world of trees with us, from their biology to cutting-edge techniques in tree care and preservation. If you'd like to support our work and help us keep bringing you these insights, consider joining us on herohero.co/talkingtrees. Your support makes it possible for us to dive deeper and share more. Until next time, take care and stay curious.